right, so quick run through question 10. River, 57 meters wide, has a current that is 4.90 meters per second west. Boat can travel at 6.5 meters per second in still water. If it must travel directly north across the stream, at what angle must the boat be aimed? So we draw our river using green, because of course all good rivers are green or something. It's 57.0 meters wide. We have a current that is 4.9 meters per second west, which means our current is heading that way. Boat can travel 6.50 meters in still water. What this means is, the boat must travel directly north across the stream. So whatever angle we pick, the boat is going to be going somewhere in that kind of direction at some kind of an angle, so that it compensates perfectly, of course, for the current. So the boat can travel at 6.50 meters per second. At this point here, we can already figure out what angle it's got to be aimed at. And then we've got not a whole lot more work to do. So first thing we're going to look at, we have the hypotenuse here. We have the adjacent side here. If I want to find the angle theta, I'm going to basically say, okay, sine theta is equal to, that's not going to be sine, that's going to be cosine, because it's of course adjacent. So let's try that again. Cosine of theta is adjacent over hypotenuse, which is going to be 4.90 meters per second over 6.50 meters per second, which means that our angle is going to be the inverse cosine of 4.9 over 6.5. And our angle here is going to then be 41.0753 and so on degrees. 41. Round up to sig digs will be 41.1 degrees. Right? What would the magnitude of the boat's velocity be with respect to the shore? All right, at this point, we'll do this in blue. We're looking for basically this side of the vector triangle, which, assuming this is A and this is B and this is C, we're solving for B, which is the magnitude of the boat's velocity with respect to the shore. So velocity with respect to the shore is equal to B, which is equal to C squared minus A squared, all square rooted. Velocity with respect to the shore equals, just do some Pythagorean stuff here, so 6.5 squared minus 4.9 squared, and then square root that, so 6.5 squared minus 4.9 squared, punching into my calculator, 4.27 when we round meters per second, and it's going to be straight north. And how much time would it take to reach the opposite shore? Well, we have speed, we have displacement, we can do this math, and let's do this in red. And so at this point in time, remembering that V is equal to D over T, we want T, so T is equal to distance over velocity, or in this case, displacement over velocity. And our displacement is 57.0 meters. Oops, that is 57 north divided by our velocity of 4.27, leave the unrounded value that's in your calculator, 4.2708 meters per second, also north. And our time then is going to be equal to 57 divided by what our answer was on the calculator, 13.346, which is going to round to 13.3 seconds. there's my answer to C. Here is my answer to B. Now, actually, I read this again. We're looking for magnitude, so you didn't actually need to say that part of things. We didn't need the direction. And our answer to A is right here. Hopefully that's a little bit helpful. It's the same process for most of the questions, but you have to just figure out which kind of a triangle you need. Whether it is this triangle where you use a side and the hypotenuse, or whether it's I'm getting blown off course and I have the two sides and then I need to find the hypotenuse. Good luck, have fun. Talk to you guys on Monday.